my power supply is turning out to be complicated rather than simple. So I'm going to have to add capacitors, but it turns out there's some problem with inrush current which I want to solve. So initially I simulated a 10,000 microfarad capacitor which gets rid of the ripple, but it has other problems. So this is a simulation of the output of the transformer with the series resistance and some diodes which are roughly equivalent to the bridge, and a 10,000 microfarad capacitor in parallel with the existing one, and with a 9 ohm load which is about just over 2 amps. So if I simulate this, whoops, I get a maximum of 38 amps in the capacitor. This one will be a lot less, 2 amps. I just think it wouldn't work. And the output current is only 2.4. The voltage goes up, so the ripple's reduced quite a lot. So the power supply would be able, the regulator would be, well, 20 volts is, I think, 1.5, roughly less than the ripple. So you get probably be able to regulate up to about 19 point something volts. But this wasn't too good. So one way of fixing that is to use more than one capacitor. So I tried that, and I get rid of all the other things. It's not one. So I simulate this, and then look at one of the. So it jumps at 12 amps, and I think that's actually a little bit, that's more capacitance, I think. Yeah, that's nearly double, actually. No, 18,800 microfarads, so the ripples are reduced. So that 12 amps is a bit high. So I started experimenting, and I haven't finished yet, with a circuit to fix that problem. It's kind of simple in a way, so that there's there's more capacitors in this one, but to stop the inrush current from being too big, there's this resistor in here, so they charge through that 1.5 ohm resistor, and then you don't want that in the circuit once the thing is fully on. So then an RC time constant circuit waits about, I think, 0.6 seconds, and then after that time the Smith trigger will turn a relay. So this is LTSpice voltage controlled switch, but that'll be a relay which effectively shorts the resistor. So then once it's running, then the resistance would drop to, I think, 0.2. So I've put 0.2, which is roughly a relay contact resistance. 0.2 in parallel with 1.5. And I'm also in this simulation simulating 100 cycles of AC, and I'm simulating it'll turn off it'll be simulating turning off and then turning back on at 3.8 seconds. So just let me clear this. So the maximum current through the capacitor is 3.6. So it's not. So you can this after the first switch off, the output of the Schmidt trigger remains high, so the relay's still on. So that means that let me just check what I'm doing here. Sorry, just let me do this again. So that's right at the boundary. So it turns off. It's off when the next group of cycles of the sine input, the 120 hertz. Sorry, the 50 hertz. I think I'm explaining this badly. So let me just. So I try to explain. So this is the capacitors charging up through the 1.5 ohm, then the Schmidt trigger, then the time constant fires, and so it's less than half a second. Because there's a delay of 1 second before the this AC turns on here. So once the 1.5 ohm resistor is shorted, then it starts charging faster. Then it runs its 100 cycles, then turns off, and then the Schmidt trigger turns back off because the this voltage across here is dropped, so that therefore this all turns off, and the relay turns off, and then we turn this back on. We turn the AC. This one comes on now, so we get 27.5 volts. 100 cycles of it. Oops, what am I doing? I just want to see. Yeah, there's a bit of a glitch there. I'm not sure why it jumps to. Because I think that what you've got to see, I think, yeah, there's a problem. I don't think that's right from the point of view of the simulation. I don't think it's working perfectly, but let's look at the 5 volt output and the yeah. So so it's sort of, I don't know whether the simulation is doing the right thing here, but in any case, what I'd actually want is to, as soon as the AC drops, then I want this whole part to reset. So that means that ultimately I want this relay to be open. So anytime the AC drops, I want to reset this. Relay goes off, 1.5 ohm is in series, so that there's a smooth charge like that, and you get the low enough, not more than, or roughly just over 2.4 amps of ripple voltage peak to peak. I mean, this currently may be good enough. So if I bring this, just as an experiment, I'll bring this closer and then show what happens. Yeah, we get it because these big capacitors haven't. Now, why is this happening? Because when the second AC turns on, I'll just look at this, and then this. It never. So it's when the second AC is on, the 1.5 ohm resistor is the relay is turned on still, so it needs to cleanly drop it here. So, and this is a simulation of you switching it off and then on within half a second, which I think is easily possible. I'm just see, so 6 amps. It still may be within the bounds of okay with the capacitor, because it's very short interval of time that it does it. If I put 3.4 seconds, then that's a little bit less. But yeah, so there's still some thinking to be done, because I still don't understand. I still want to know how to make this properly, but it's getting more complex. But I guess what I really want to do is to make sure this time constant. So you would short that capacitor, but unless you discharged all of these, oh wait a minute, what voltage? No. So because I think that the 5, it's still, yeah, it's still enough coming out of the 5-volt regulator to trip the Smith trigger. It never, because the input of the Smith trigger, this one is a differential one, so it's at it has to go below 2.5 volts, and I need to set the hysteresis to make the simulation more correct. But yeah, still haven't figured it out, but I've learned a little bit more about LTSpice, which is good. I hope my rambling on has made some sense. It's difficult to. I would have thought that I've heard that explaining something makes you understand it better, but I'm wondering whether that actually has to be if you can see someone in the room who might be asking questions. Because yeah, I haven't had any epiphanies while I'm talking. Anyway, thanks for watching.